What is a non-conservative force? A non-conservative force is that force whose work done is not path independent, that is, the work done depends on the path taken by the object. It converts the macroscopic motion to microscopic motion. The effects of these microscopic motion are affected by the macroscopic motion. To get a clear picture on non-conservative forces, we shall discuss more about it in examples in the later sections of this article. What is a conservative force? Unlike non-conservative forces, conservative forces are those forces on moving particles whose work done is independent on the path taken by the moving particles. The entire work is path independent, that is, the macroscopic effects have no relation with the microscopic effects as they are negligible in comparison. We can rule out these effects as they have no direct effects on each other. We shall discuss about the examples of conservative forces in the below sections of this article. Non-conservative force examples. The examples of non-conservative forces are given in the section below. Friction. In friction, the microscopic effects and macroscopic effects are related to each other, as the macroscopic movement of objects are responsible for tiny irregularities meshing with each other on surface. This is a clear indication that the macroscopic movement is affecting the microscopic effects to come into action. Pushing a person. Pushing a person is an example of non-conservative force, because the effect of work is path dependent. Had the person pushed from a different angle, the effect would have been different. Hence we can say that pushing of a person is a non-conservative force. Pulling a person. Like pushing a person, pulling also is an example of non-conservative force. The effect due to the work depends on the path. If the person is pulled by some other angle, then the effect would be different. Hence we can consider pulling a person as an example of non-conservative force. Air drag. Air drag is a non-conservative force because the airflow over the ball or any aerodynamic object moving through the air film will affect the movement and path of the object. This way we can say that the macroscopic effect and microscopic effects are interrelated to each other. Viscous force. Viscous force is an example of friction between the layers of fluid. When the layers of fluid are moving, the resistance between the layers comes into play. Here the movement of fluid layers are considered as macroscopic effect and the resistance between them is microscopic effect. This shows that the movement of fluid particles give rise to microscopic effects, hence the viscous force can be termed as a non-conservative force. Electromotive force. Electromotive force is the induced voltage inside a cell when a magnetic field changes its direction or magnitude. The generated EMF depends on the magnetic field that is generating it. If the direction of the magnetic field is different, then the polarity of the generated EMF will also be different. This justifies the fact that electromotive force or EMF is a non-conservative force. Induced electric field. As discussed in the above section, induced electric field depends on the direction or polarity of magnetic field that is producing it. The polarity of induced electric field will be different if the polarity of the magnetic field is different. Hence we can say that the force due to induced electric field is a non-conservative force. Collision between a baseball bat and ball. Collision between two objects can be considered as an example of non-conservative force. This is due to the fact that if the angle of collision changes, the entire pathway of other object changes, implying that the work done has an effect on objects that is path dependent. The noise created by the collision is an example of microscopic effects coming into picture due to macroscopic movements, in this case is baseball bat hitting a ball. Crashing of car into divider. Crashing a car into divider is yet another example of collision. As discussed above, collision has an effect on the objects that is path-dependent, and the loud noise which comes after the crashing of car is an example of microscopic effects coming into play due to macroscopic movements taking place, which in this case is crashing of a car. Hence we can say that the crashing of car is an example of non-conservative force. Falling of a remote on the floor. Falling of a remote is considered as non-conservative force, as the noise that is created on microscopic levels is due to the movement of macroscopic objects, which in this case is the remote that is falling. Slapping. Slapping a person is considered as a non-conservative force because the sound produced by the slapping is an example of microscopic effects taking place due to macroscopic movements. The direction of slapping also affects the consequence. Hence it is a non-conservative force. Clapping hands. Clapping is of different forms. We can change the sound coming out of clapping by changing the way we clap. This means that the force required to clap is non-conservative, as the effect depends on the path taken by the hands for clapping. Punching a bag. Punching is a similar example to that of slapping a person. This is because the punch can come from any direction, and every direction has a different effect. This is why it is a non-conservative force. Tension. Tension is a non-conservative force, as the effect it creates depends on the magnitude of the tension in the spring or string. Conservative force examples. The section below tells us about the examples of conservative force. Gravitational force. The gravitational force follows a simple formula and does not change its effect on different objects. Hence it is considered as a conservative force. Elastic force. Elastic force depends only on the stiffness, no path dependency exists for such kind of force. Hence we can say that it is a conservative force. Magnetic force. Magnetic force will not produce different effects on different objects, only two things can take place: attraction or repulsion, depending upon the poles. Hence we can say that the magnetic force is a conservative force. Electrostatic force between two charges. Electrostatic force is analogous to gravitational force. It does not change with change in electrons. The effect produced is same on all charges. The magnitude can depend on the number of charges, but the net effect remains the same, hence it can be considered as conservative force. Weight of an object. Weight of an object is a conservative force, as the effect of gravity does not change, only the mass affects the value of weight. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.